Good morning. Lesson 5. Today's lesson is a little more complicated, but there's really one thing you just need to take from it at the end of the day, and we'll get there. We just got to work through. They want you to understand it a little more deeply, like why this works, okay? So in the first question, they're going to show you a grid, okay? And there'll be a triangle in it, okay, like that. And what they want you to notice is that if you make the mirror image, the translation of the triangle, it makes a rectangle, right? And that if you figure out the area of the rectangle and cut it in half, it gives you the area of just the rectangle. So what you have to do on your on the little graph that they've drawn for you is draw the mirror image of the rectangle, figure out how many squares it covers, and cut it in half, right? And then just fill in the area. Pause the video, go do question 1. Okay, question 2. They're talking about base and height. How do you figure out what the base and height are for a triangle, okay? Base is easy because any of the sides can be the base. It doesn't matter. And but the height sometimes can be a little bit tricky. So say we have a triangle like this, a right triangle. Super easy because the grid or a ruler can tell you, like, we could use this as the base. So you would just measure that. Or we could use this as the base or that as the base. It doesn't matter. But to find the height, you want to look at the vertex that's opposite your base. Okay? In a right triangle, it's super easy because they've already made the line for you. So that's going to be your height. If you get into a triangle like this, you can use any side as the base. And then you've got to look at the vertex opposite. So the highest point, you want to drop a line at 90 degrees and measure this. This is your height. Okay? Sometimes you're going to get like a crazy drunk triangle that goes like that, like an obtuse triangle. So if we use this as our base, problem is that none of this is the true height, right? Because it only goes to here, but the triangle actually gets taller over there. So what you have to do is extend the base as if it was there, and then drop a 90-degree line, and your height will be here. Most of the time your height is inside the triangle, but once in a while you'll get a triangle like that where you have to go out here to get your height. Again, pretty simple, okay? To figure out the area, right, because you have to figure out the area again, it's still on the graph paper, so you can add, like you can just count the squares and it'll be a whole number. It's not going to be like 4 1/3 or 5 1/2 or anything like that. It's a whole number. So you can count up the squares and sort of figure out where the little pieces fit in and find the whole number. Okay? Pause the video, go do question 2. All right, question 3. So they're showing you a grid, right? They're showing you a grid, and you've got a triangle on it that doesn't cooperate with anything we've seen already. Well, I suppose it should be on the line, so here, right? Not here. But it doesn't cooperate, and they're saying, is this half? Well, I can tell by looking at it, it's not half, right? So they want you to shade in half of the grid. Does this triangle cover that? No, it doesn't. Okay? Now, one of the things you have to remember in this question that is a little bit tricky if you don't remember it, but makes total sense if you do, is how you name a triangle, right? So you have a triangle. It's got 3 vertices. This is triangle ABC, or BCAC or CBA, it doesn't matter, but it has to be in order. It can't go like, you have to go clockwise or counterclockwise, starting at any corner, okay? I don't think you can really screw it up with a triangle. With a quadrilateral, you can. You can't skip back and forth. You have to go round in a circle, okay? So follow the instructions closely. When it says, because they're gonna show you the triangle inside of a grid, right? And they're gonna ask you, they're gonna call this, maybe they call this A, B, C, D, and that's the whole area of the rectangle, right? They'll say it's rectangle ABCD or DABC or whatever, right? And they'll tell you to shade parts of this or parts of that, so you have to pay attention to what it is they're actually telling you to shade, because then this might be called X, Y, Z, but they're gonna ask you to find like the area of this too, which they might call XTY. So you have to pay attention to what the letters are actually asking you to shade. From there, it's very easy, but make sure you remember how to label a triangle, okay? Pause the video, go do question 4. Okay, question 5. So what they want you to do is figure out, again, the exact same thing you were doing in the above question. They've got the grid, they've cut it in half, and then there's a triangle within there, right? That if you take the area of this, the whole thing, and separate this part, it gives me this part, this triangle, right? So you're gonna take the area of half the grid. So say on the first one, they've got a grid that is 1, 2, 3, 4, 5, 6, okay? 3, 3, 1, 2, 3, 4, 5, 6, and by 4, right? So cut it in half again. My squares are nowhere near square, but you get what I mean, okay? 4 by 6. Now, they've got it cut in half. Well, if I know that this is 1, 2, 3, 4 by 1, 2, 3, 4, 5, 6, 4 times 6 is 24. So that means that this half is 24 divided by 2, which is 12. Right? So I know that this half is 12. Now, they've got, let me see, they've got it coming down at number 3. 1, 2, 3. They've got this triangle drawn there, right? So this is A, this is E, this is B, this is C, I assume this is D. Yeah. Okay? So they're saying that if we can figure out what one of these pieces is, which I can, because this is a right angle triangle right here. It's 1, 2, 3, 4 by 1, 2, 3. So that means this piece would be 4 times 3, which is 12, and then 12 divided by 2, because that would be half of the rectangle that it actually is, right? So that means that this piece here is 6. Which means that this piece here is also 6, because if this is 6 and this is 6, we know the whole thing is 12, and 6 and 6 makes 12, okay? So you go do the next question, divide the whole grid in half, and then figure out that right angle triangle piece that you can find, okay? All right. All right, pause the video, go do number 5. Okay. You need what? Oh. Okay, so question, the next 2 questions are interesting only because they're showing you how to rearrange a triangle to make a rectangle, okay? So the first person, Jan, she's got a triangle, right? Now, one of the things you have to remember in this one is what the symbols mean, okay? Now she's cut the top off the rectangle, okay? She's cut it in half, and there's marks like this, okay? Those marks you should recognize. They mean those two pieces are equal. So the length of this and the length of this are equal. So this is one half, this is the other half. She's cut the height in half, okay? And then she took this skinny triangle and she moved it to there. So if you could pick it up and rotate it, it would fit there. She took this chubbier triangle and moved it there. So if you could pick that up and tip it down, it would fit there. So now she knows that half of the height of the whole thing is the height of this, right? And that the base is the same. So it asks you, what is the width of her rectangle? So you need to measure that. How is it related to the base of the triangle? Well, the width of her rectangle is the exact same as the width of her base of her triangle. What is the height of her rectangle? Well, it's half the height of her triangle, right? So, and then they want you to write a formula using the base and height of the triangle from Jan's method. So you're going to find, this is the one thing you need to take from this lesson. The area of a triangle is base times height divided by 2. Okay? I prefer to write it like this. Base times height divided by 2. This line means divided by 2. So I do my base times the height, I divide it by 2. Okay? Now you got the second guy, Ian. He does the same thing but a different way. He goes sideways instead of up and down, okay? He's got a triangle. Looks like this, okay? The height is not exactly in the center of it. But, so he draws a triangle that it cuts the triangle in half. So that this and this, that line means those are equal, right? And this and this are also equal. But they're not the same length as those two. So this means this is equal to this, and this means this is equal to this, but these two are not the same as those two, right? Otherwise they'd all just have one line or two lines. It would all match. It doesn't, okay? So he takes the triangle, or the rectangle, pardon me, and drops it that way. These are all right angles. Okay? What is the width of his rectangle? Okay? What is the height of his rectangle? So this versus the whole thing. Now my drawing's not to scale, right? But it's supposed to be half. That the width of the triangle is twice the width of the rectangle, but the height is the same. Okay, so it's got half the width. And again, this time I went base divided by 2 plus height divided by 2. Or times, pardon me, not plus, times. Okay, go do that question. And come on back. Okay, so they want you to draw with a new triangle, which looks sort of like that, okay? How would each of them do it, right? Well, Jan cut the top off of her triangle, and the two lines had to be at half, right? So I'm looking at halfway across here, and I don't know, it's about like that, right? To make that half. And then she dropped a line here, and she took this piece. Oh, I gotta make my I gotta make my rectangle. She went out to here and out to here, okay? She took this piece and she put it there. She took this piece and she put it there, right? So, the other guy, similar triangle, right? He took these pieces and put them up top. So he made it double the height, right? Double the height, and took the extra pieces and put them up top. I drew that wrong. Let's try that again. All right, so his triangle is a little bit tipped this way, like that, right? Okay, he went inside, drew this, then went and drew the same one again to the same height. So this skinny piece went here, this chubby piece went there. Okay, so that's how you're gonna draw that. How are the bases and heights of jans and triangles related? They're the same, they're just flipped. Explain why they get the same area. Well, it doesn't matter if it's 2 times 4 or 4 times 2. It doesn't matter what number comes first, they're both the same. Okay, last page. You need to measure the heights and bases of the triangles and figure it out for yourself. So they give you a triangle. We assume the base is the bottom, but it doesn't need to be. You measure that. You drop a line from the vertex opposite. You measure the height. Base is here. Height is here. Right? Height. You go base times height. So whatever this is, let's pretend it's 5. And whatever this is, let's pretend it's 4. Hi, Indy. So that's 20. But that would give us the whole triangle, right? Or the whole rectangle, right? So we got to cut it in half. Indy, stop. 20 divided by 2, so that would give us 10. Now, because it's area, remember that it has to be squared, right? So we're counting in centimeters, so it's going to be centimeters squared. So find your base, your height, times it by each other, and then divide it by 2. Easy breezy. Go do question 6. Okay, question 7. You have to find the height of the triangle. I told you how to do this. We're going to see crazy triangles. Pick a side, make it the base. Look for the vertex opposite. Draw a 90-degree line straight down to the base. All you have to do in this question is draw in the height. Remember the drunk triangle that's way leaning over like that? Here's your base. But you have to extend it to find the height over there, okay? Make sure you draw in the little 90-degree box so you show me that you're understanding that the height forms a 90-degree corner with the base, okay? Go to question 7. Okay, so question 8, opposite of what you just did. They're trying to trick you, but you can't be tricked. So they give you a triangle, right? They give you the height. I'm upside down. If this is the height, we know that the height forms a 90-degree corner with the base. Is this a 90-degree corner? Not even close. I eyeballed it, so this isn't 90 either, but it's close, right? Which means that this is the base. Could this be the base? Absolutely, but then the height would come up here, right? Could this be the base? Absolutely, but then we'd need a 90-degree corner that came there, right? You can choose any side to be your base. Generally, you want to choose the one that has a vertex opposite so that it's easy to drop the 90 degrees, right? So go draw in the heights. Oh, they just want you to label which one the base is. So they've got the triangle A, B, C, and if this is the height, what is the base? This is the base, and how do we name the base? AC or CA, your choice, makes no difference. Okay, go do question 8. Last question. Question 9. Measure the lengths and sides on the heights of this triangle. I did not have a ruler with me this morning, so I just sort of eyeballed it. My math will be correct even if my measurements are not on the answer sheet, right? So they've drawn you a nice triangle, but they really tried to be super tricky and put it on an angle on the page so that it wasn't even, I can't even draw it on an angle. Okay, the base is on an angle, and then it sort of goes up to, and looks like it's an isosceles triangle, okay? But see what they do? They turn it, so they try to be tricky, but we can't be tricked, right? So they tell you that there's a line here with a 90-degree box. So we know that this is one base and this is one height, right? But then they use this one as the base, and then I gotta draw a 90-degree line here. So that's pretty close, right? So if this is the base, this is the height that goes with it. On this one, if this is the base, I go to the vertex opposite, I draw a 90-degree, I drop a 90-degree line, right? So they want you to measure all these lines, okay? And then figure out what the area of the triangle is. So let's assume, all right, let's say that this is, that the height is 6 and the base is 5. Well, I know that area equals base times height divided by 2. Remember, my line means divided. I know that's new for lots of people, okay? Base times height divided by 2. So that means I've got 6 times 5 divided by 2, which means I've got 30 divided by 2, which means the area is 15. Now, if this is 6 and this is 5, the numbers are exactly the same. It doesn't matter what order you put them in. 5 times 6, 6 times 5. It's all the same. So you don't need to, like, if your numbers are the same or they both multiply to 30, like maybe it was a crazy triangle and one of them had 6 times 5 and one of them had 3 times 10. They both equal 30. Half of 30 is always 15, so it doesn't matter what order the numbers come in if they all multiply to the same thing. You could have 15 and 2, 5 and 6, 30 and 1. It could be like a super skinny triangle. But as long as the numbers are the same, the area is the same. And that should make total sense to you because it shouldn't matter. The numbers, clearly the area of the triangle is always the same, no matter where you measure from, whether it's this base and this base or this base and this base. The triangle doesn't change area because you measure from a different place. It's always the same triangle. Okay? So finish your last one. Have a good day. I miss you, and I'll see you soon. Bye.